In the previous lesson, you worked on classifying angles by size and angle pairs by their relationships to each other. Today, we're discussing more angle relationships within a triangle and how we might use those relationships to solve problems. Before we dive in today, you'll want to complete the pre-video activity. If you haven't completed the pre-video activity, pause now and complete it. Done? Great! Set the triangle you cut out aside to use it in just a bit. Let's start by taking a look at the interior angles of this triangle. Interior angles are the angles inside a shape where two sides meet. You might remember that the sum of all three interior angles of a triangle is 180 degrees. We can use the triangle you cut out in the pre-video activity to demonstrate that fact. Start by carefully tearing off each of the interior angles like this. Then, when we line these angles up, making each one adjacent to the next, we can see that these three angles form a straight line, which means their measures sum to 180 degrees. We already know some interesting information about the angles in triangles. I wonder what else we can discover. Let's see. If we have interior angles, does that mean there are also exterior angles? When we extend the side of the triangle like this, or like this, we create angles outside of the triangle. Those are exterior angles. In the last lesson, we looked at how to describe pairs of angles. How would you describe the relationship between an exterior angle and the interior angle right next to it? Aha! These angles are adjacent because they share a side and a vertex. Do these angles also have a special relationship according to their measures? They are also supplementary since they form a straight line. And since these angles are supplementary and adjacent, we can also call them a linear pair. We have a lot of great information about the interior and exterior angles in triangles. So let's see how we can use them to solve a few problems. My first thought is that all three interior angle measures sum to 180 degrees. But if I only have one, I can't really use that to find the other two. But maybe I could use this exterior angle instead? I also know that an exterior angle and its adjacent interior angle are a linear pair. That means that the sum of their angle measures is 180 degrees. If the exterior angle is 100 degrees, then the adjacent interior angle must be 80 degrees. Now that I know that angle, I can find the last missing interior angle using the fact that all three interior angle measures sum to 180 degrees. 30 degrees and 80 degrees make 110 degrees, which means the missing angle must be 70 degrees. Great work! We were able to use our knowledge about triangles and angles to solve this problem. Let's see how you do with a couple more. Pause and solve for the missing angle measures in the two triangles. In example 2, I see a square in the vertex of this interior angle, which means it is 90 degrees. I know that the right angle and the adjacent exterior angle are a linear pair, so the exterior angle must be 90 degrees as well. Now I can find the missing interior angle. The measures of all three interior angles must sum to 180, so the missing interior angle is 30 degrees. And in example 3, since the exterior angle is 40 degrees, the adjacent interior angle is 140 degrees. Then we can find the remaining interior angle, which is 20 degrees. Wow! With just 2 pieces of information about angles of triangles, we were able to find these missing angles. Let's review what we know so far. First, we know that the measures of the 3 interior angles sum to 180 degrees. Also, an exterior angle and its adjacent interior angle form a linear pair. Are there any other patterns that you notice? Pause now and consider the relationship between an exterior angle and the 2 non-adjacent interior angles. What do you notice? Record any thoughts in your guided notes. I noticed in the first example that 70 plus 30 equals 100. In the second example, 30 plus 60 equals 90. And in the third example, 20 plus 20 equals 40. It looks like the measure of the exterior angle is equal to the sum of the measures of the 2 non-adjacent interior angles. How can we tell whether this is true for every triangle? Let's use this generic triangle along with what we already know about triangles and angles. We know that the measure of the 3 interior angles of a triangle always sum to 180 degrees. And the measures of an exterior angle and its adjacent interior angle also always sum to 180 degrees. Since both of these expressions are equal to 180, they are equal to each other. Interesting. Since A is on both sides of the equation, we can cancel it out and show that for any triangle, the measure of the exterior angle is equal to the sum of the non-adjacent interior angles. We've just discovered something really cool. Now, let's put it to work. Let's wrap up with a couple of examples. Pause now and try these out using our new fact about exterior angles and their non-adjacent interior angles. For example 4, I know that 60 plus x must equal 115, so x must be 55, making our missing angle measure 55 degrees. And for example 5, we can find y by simply adding the 2 non-adjacent interior angle measures. 42 plus 29 is 71, making the missing angle measure 71 degrees. Today, we learned that the sum of the measures of the interior angles of a triangle is 180 degrees. We also learned what an exterior angle is and its relationship to both the adjacent interior angle and the 2 non-adjacent interior angles. We also learned how to use these facts to find missing angles in triangles. When you finish these guided notes, you can move on to practice levels 1 through 3. And remember, math is everywhere. Keep exploring.
Hey, hey.